In this section, we're going to be working through our first example of a program that has a custom class. We're also going to have a short discussion about something called UML, or Unified Modeling Language, which is going to be kind of a generic way that we have to represent classes, whether they're in Java or any other object-oriented language. Up on the screen, I have some source code from the textbook. So this particular program is designed to simulate rolling a bunch of dice and then counting how many of them are snake eyes, meaning both of them are ones, and then computing the ratio, right, of how many snake eyes occurred per whatever number of rolls happened. Before we dig into the code, let's go ahead and compile this and run it. So here we can see what the output looks like. Number of rolls 500, number of snake eyes 11, ratio 0.022. Right, so we're saying that, this program simulated rolling dice 500 times, and each of these were a different six-sided dice. And then once we looked at all those results, we counted up 11 times that both of those dice ended up on a 1. We did the division and we found out that the ratio was 0.022. We can even play with this a little bit. Let's actually go in here and change rolls. This is a variable, we'll talk about it more later, but this controls how many dice we roll. So let's compile, run. And then on the right I have my new output. So I can see here that now I'm doing 5,000 rolls. I got more snake eyes, right? I got 133, and then I have a slightly different ratio, right? Remember that there's some random number generation going on. So these ratios, these number of snake eyes, will not actually be the same, right? It won't be 10 times as much as the first one, right? Even though I'm rolling 10 times as many dice, because the whole thing is random, I may not necessarily get just 10 times as many snake eyes. Let's go ahead and walk through the snake eyes program. So over here, the first thing I have is kind of a standard comment header, right? So a basic explanation of what the class does, who wrote it, and here they've included kind of the name of the class. Scrolling down, I have the main class, right? So this is kind of what we've been doing before, which is we have one class, here named Snake Eyes, and then inside that class, we just have a main method. That's what we've been doing so far. In a minute, you're going to see we'll jump over to Die, and that's actually the new custom class that we've implemented. Continuing to read through Snake Eyes, we can look up here at line 7, and we'll notice that Snake Eyes, right, is the name of the class, which also means it has to be the name of the file as well. And then the whole class is public, right? Just saying that this class, anybody can use the stuff inside of it. Scrolling down, we see a comment that describes more exactly what this program is doing. So here we can see it creates 2 die objects, right? That's what we're going to be building ourselves, right? That isn't something for the Java libraries. And then rolls them several times, counting the number of snake eyes that occurs. So just a detailed summary of what this program is supposed to be doing. So over here we have our main, which is pretty much the same thing we've been seeing for a while now. Then our open and close bracers, right, to define a block of code that is actually going to make up that main. Inside of main, we first see this final int rolls equal 5,000. So I mentioned a minute ago, this is actually the variable, or a variable, that stores how many times we want to roll a die, right? We just kind of rolls set equal to how many times we should roll them, how many pairs we should roll. And then over here, right, we have the keyword final, and that's just saying that this rolls variable, right, the contents of it won't need to change in the future, right? It's going to be 5,000 when I start my program, and it will not change while the program is running. After that, we have another line here that declares 3 ints, num1, num2, and count. And those are just used to store the information we're going to gain by simulating all the dice rolls. So num1, for example, will store the result of rolling one of the dice. Num2 will store the result of rolling one of the other dice. And count is what we'll use, and we'll be incrementing this over time, in order to count up the number of snake eyes that we see. These lines over here are maybe a little bit familiar and yet different than what we've seen before. So over here, I'm creating 2 variables, die1 and die2, and you can see I'm using the new keyword over here, so you know we're going to be creating an object and storing them into these variables. But what's different than what we've seen before is just this over here, the word die. So die is actually a custom class. It's not something that comes with Java. It's not something like scanner or math that's already available to us. Die is actually a custom class that's designed to represent a die within our program. It's not something that Java already provides to us. So over here, right, we create 2 instances of die, right, 2 different dice objects, and those are what we're going to roll throughout the rest of our program. Continuing down, I have this for loop. And this for loop is what's going to roll those dice a whole bunch of times. Looking in here, right, I can see that I have a variable, right, that's going to be changed over time. And then for this, right, I'm starting roll as 1, and then I'm going to go continue looping as long as roll is less than or equal to rolls, right? So it's going to go up to that 5,000. And then over here I have my incrementer. My incrementer says, roll increases by 1 each time. Once roll is 5001, this thing here will be false and the loop will exit out. And it'll jump down here and go to these print statements. In the meantime, while roll isn't 5001, it'll loop and it'll run this code here. So in this code here, we're going to use our custom classes, right? And we create objects of those, objects called die1 and die2, and we're going to roll each of them. That's kind of a method we will also have implemented ourselves, right? That's something from our custom class. So we'll roll both these die, and then this method here is actually going to be returning an integer. It's going to be returning what is the number that the die rolled. And then that number is going to be stored into one of the variables we created earlier. So over here, we're going to be storing it into num1. And kind of the same thing happens over here on this line. We roll this second die, and then we store its result into num2. So at this point in my program, I'm effectively rolling 2 dies. Once those have been rolled, I can actually check to see whether I have snake eyes, right? If both of them are equal to 1. And that's what this if statement here is going to do, right? So this if statement has this conditional that says, is num1 equal to 1, and is num2 equal to 1, right? Did both die give me a 1 as a result? So if both of them did, right, if that's true, then I'll increment count by 1. So effectively, right, every time I see that snake eye, right, the double ones, I'm just going to count it. So over time, I'll do this simulation, right, rolling this dice, and whenever I see snake eyes, I'll count it up. Once that loop has exited out, I'll jump down here to the final part of my main, which is these 3 println statements. So the first one here, right, is print number of rolls. So that's just printing the variable that right now has 5,000 stored into it, right? That's just telling us, this is how many times we simulated rolling our dice. After that, we have a line that says number of snake eyes, and that just prints out the value of count, right? So that's what we were incrementing each time num1 and num2 were equal to 1. The last thing here is a print for ratio, right? Which the ratio is just going to be the division of count by rolls, right? To figure out what fraction of those end up being snake eyes. And you'll of course notice that count, right? Count is originally an integer, but we're going to cast it into a float, just to make sure that this whole division here happens with floating point math. The next thing for us to look at is the die class, which is our big new feature for this chapter, right? It's a custom class. So over here, looking at this window, I kind of have a lot more code. Up top, I have the same thing as the other file, as the Snake Eyes program, in that I have this simple header that tells me a little bit about what's contained in this file. Scrolling down, I have another class, right? Public class die. In general, classes are separated into 2 regions. One for variables, or we'd call them member variables, instance variables, and one for methods. So that's what we have, the rest of the stuff we have here. So this is just a general convention. The idea being we want to put all our variables up top, all in one place, so that somebody reading the class can look and see all the information that's going to be available to them, right? All the different variables they can access in each of the methods in this object. If we don't do this, if we kind of scatter our variables all over the place, then it won't really be clear what we have available. For this example, we only have 2 variables. We have our max variable and our face value variable. So the max variable over here, this is going to be something that represents how high I can roll, right? How many sides are on the dice that I'm rolling? In this case, I've set it equal to 6 to represent that I'm rolling a 6-sided die. If we wanted to roll a bigger die, for example, something with 20 sides, we would replace this number here with a 20, or whatever number of sides your dice happens to have. The next thing we have is face value. But what this variable does is it stores the current value on the die, right? What is the last thing we rolled? What is facing upward? And this doesn't have an initial value. We'll actually set it up in the constructor. So let's move down to the rest of this class. The first thing we have is the constructor. Remember that the constructor is a method that's automatically run when we create an object, right? When we create an object from a class. The purpose of a constructor is to set up that class, right? So for example, here you notice that there's code inside to set face value equal 1. We're using this constructor, since it automatically runs, we're using it to set up the variables inside of this class. In a more complex class, the constructor is going to be where we set up all the instance variables, all the variables inside of this class. The constructor is simply a method that's guaranteed to run when you first create an object, right? So it gives us a chance to set the scene before any other methods are called on the object that we've just created. Die is pretty straightforward, so we don't do all that much. Let's scroll down a little bit and take a look at the rest of the methods in this class. So the rest of these are normal methods. They're not special like the constructor. The constructor is this special case, right? The first thing we have is the roll method. So the roll method is what my main program was calling, right? That's what Snake Eyes is calling over here in order to simulate a die being rolled. So this is the actual implementation, right? Snake Eyes just knew about it in terms of doing die1.roll or die2.roll, but this die class, that's where the actual implementation for it is, right? The actual code that makes that possible. So over here we have the method called roll, and it has the return type int, right? Because the size of my dice are all whole numbers, right? They're all integers. The word public over here is just saying that anybody should be allowed to call this method. Again, this is something we'll talk about in more detail later on. So this method itself is relatively straightforward. There's just 2 lines of code in here. Most of the work is done here on this top line. Face value equal int math.random times max plus 1. The idea is this. Math.random returns a double between 0 and 1. So we have this multiplication here, right, of that random number with the number of sides of my die. Essentially, we get some fraction of the die's highest value, right? So if the math.random returns 0.5, we get back 3. If it has some other value, then it's going to be some other fractional number up to max. The only kind of issue with this is that this here will give us a double, and then we have this cast here, right? We want to have an integer afterwards. But this cast is effectively throwing away the decimal part of what's computed here, right? So point whatever, the whatever part is just lost. As a consequence of that, this really ends up looking like a random number between 0 and 5. And so what we do is we add 1 to it, and that gets us to the range we want, which is 1 to 6. Overall, roll is really the heart of this class. There's a couple other methods here that let us get information out of the class, but this is really the thing that we're going to use a lot, right? This is the thing we're using over in Snake Eyes. So let's scroll down again. We have 3 things left to look at here. The first is set face value. So this is a mutator, right? The job of this is to change the value within the class. So here I have void, set face value, and then int value. So this is the name of the method, and this is the name of the parameter. Here we're taking in a value that we want to put on the die. Over here I first have an if statement. And what this if statement is doing is it's making sure that I'm setting a valid number for the die. We already said that the die has a certain number of sides, for example 6, and what this is doing is it's making sure that I'm not trying to set, for example, a negative face value or a face value that's larger than max, right? I want to prohibit those things. I want to make sure that whatever it is that I'm putting on the face of the die, that is legal, right? It's legal in terms of the maximum value I can have on this die. So once that if statement runs, we'll validate that it's a good value upon the die, and then we'll do the assignment here, right? Face value equal value. So that parameter will now be assigned to face value, so that'll be the number that's on the die. The method that's complementary to this is get face value. So instead of the previous method where we actually change the state of the object, here we're just returning information from the object so that someplace outside can see what's going on. So here we have int get face value, right? So this is a method that returns an int. And inside, this is very simple. We just have return face value. So return face value, right, is just returning whatever is the value on the die. And I guess one thing here to note, right, is that this face value, this variable here that it's returning, that's the one that was defined up here, right? That's defined as a member variable or an instance variable within this class, right? So this is part of all dies, right? All dies have a face value variable, and so every die, all the methods inside of it can use that variable, right? Can use face value or they can use max. The last method we have here is called toString. This is kind of a standard method that a lot of classes will implement. A lot of people like to use this for debugging. The point of it is that this is a method that will return a string representation of your object, right? It'll tell you what's going on inside of it. So as you can maybe imagine, this is useful as you develop your program because you can call this to check what is going on inside of your object. So over here we have this first line that says string result, right? So this is creating a variable equals integer dot toString face value. So over here, this thing here this is actually a class that's built into Java. So there's actually a class called integer that's always available to you, and it provides you some functionality. The bit of functionality we're using over here is something called toString. So this method here that we're invoking, what this is doing is it takes in an integer, right, face value, and then as a whole, it returns a string, right? It returns a string representation of that number. So here, right, whatever number it is, we would now have a string for it, and then that string gets assigned into a result. And then that result is returned out of our method, right? And then we can display it. That about covers the entirety of the die class. The one thing I do want to note before we talk a little bit about UML, or Unified Modeling Language, is the idea of instance data. So over here, right, we had two different variables that were associated with the die class. The thing you want to remember is that these are unique to each object, right? So each die is going to have its own face value, right? There's not just one face value that all your objects have to store. Every time you do a new, right, every time you make a new object, that object is going to have its own working space, right? It's going to have its own variables, and it can put whatever it wants in those variables, right? It's not forced to share with anybody. This data is effectively unique, right? It's not being used by anything else. The last thing for us to discuss in this section is the idea of Unified Modeling Language, or UML. So let's glance up at the code we've been talking about. If I were to look at die right now and ask myself what methods it has, I would need to do some work. I would need to go and scroll through this file and see everything that's available to me. That is maybe not the best thing. You can imagine that if somebody else is trying to understand a huge code base with a ton of classes in it, they're not going to want to scroll through a ton of files and try to figure out everything that's there. In order to address this kind of issue, right, of understanding large, complex programs, people introduce the idea of using a modeling language to represent that program. This is an example of a UML diagram for the program we've been talking about. So here we have 3 rectangles. Each of these rectangles is actually representing a class. So over here you'll hopefully recognize we have snake eyes, we have die, and we even have the math class. Remember that we had to use in order to get a random number. The goal of this diagram is to be a more concise representation of the program that we've just talked about. It's a lot easier to use this diagram to look up what variables or methods are available as opposed to just reading through the source code, right? That'll take me some time. Here things are shown in terms of a high-level view. You'll notice here that the syntax looks a little bit different than what we've been using in Java. You may recognize the names of the methods, right? Set, face, value, but you'll notice a lot more colons, plus symbols, minus symbols, and then those arrows as well. We'll talk about that in a minute. The reason why that syntax looks different than what we've seen in Java is simply that UML isn't limited to one programming language. The idea behind UML is that we would be able to use the same notation for a program in any object-oriented language. So this is just as valid for C++ or C# as Java. Let's take a look at the syntax that's being used here. So over here in Snake Eyes, back in our program, we just had a main method. And that's what's indicated by this line here. The first part of this line is a plus symbol. And that's the UML notation that means the same thing as the keyword public, right? It means anybody can access this. The opposite of that, right, something that's private, is represented by the negative. That means that this thing is private and nobody can access that information except for that class. The next part over here is main, right, the actual name of the method. So that stays the same. What doesn't stay the same is the type for the method. Normally we're used to seeing something like void main, but in UML, the type actually goes after whatever is being typed. So the syntax is method, colon, then type. So this is saying a main of type void. In the parentheses, we have the arguments still. Here it's called args, and then we have the colon, right, which is again for typing. So the type of args is string bracket, right, string array. This syntax is a little different than Java, but the thing to remember is that, again, UML was meant to support more than just one programming language. It's meant to be very generic. Looking over the die class, we see a couple more things. First of all, we notice that this rectangle is essentially divided. So up top, we have all the variables, and then at the bottom, we have all the methods. And in UML, they actually like to use some different terminology. So for here, they'll call these attributes, and over here, they'll call these operations. So looking up at our attributes, we see that we have max and face value. And these are set up kind of the way we saw main. We have kind of our name of our thing, right, our name of our variable, and then a colon, and then the type, right? So this is saying that we have an integer called face value. And then the minus just means it's private. Same thing up here that defines max, but then we also have an =7 to represent that that is initialized to that value. On the bottom, we then have the operations, and so we have the 4 different things. We have the role, we have the set face value, get face value, and toString. And again, all these are using the colon and the type name, right, to represent what they return. Here we have an integer, void, integer, string. And the only method here that has a parameter is set face value. And here we can see it just takes in one thing named a value whose type is int. This diagram doesn't really include any details for math. We just want to show that math is a class that is involved. It's providing some functionality that's needed by our program. If we wanted to be more complete, we would fill in this class with the actual information for that random method that we called to generate our numbers. One other thing you'll notice in this diagram are these arrows. And we're actually going to see those a lot more once we start talking about inheritance, or once we start talking about programs that are more complex. The purpose of the arrows is to tell us how the classes are related. In this diagram, we're just using these straight arrows. So these straight arrows represent the idea of an association. So Snake Eyes is associated with dies, right? So Snake Eyes knows about the die class, and it uses die to get its work done, right? So it's using die for that simulation that's doing it again and again and again. The arrow is one way because die doesn't rely on Snake Eyes, right? Die doesn't use Snake Eyes for anything. Looking down here, we notice that die is associated with math, right? So the die class, that is having to use the random method inside of math, right? So it's using that method in order to calculate the result of rolling the die. Notice that there isn't an arrow from Snake Eyes to math. The reason for that is that Snake Eyes doesn't directly use the math class. Instead, it just uses the die class, and the die class in turn uses the math class. Overall, these high-level relationships between your classes can be very useful. They tell us how our program is structured, right? They tell us what depends on what. So that if, for example, I want to make a change somewhere, I'll know all the parts of my program that might impact.